This time, I'm going to talk about neural network in Python. Neural network can be used in many fields. For example, we can build a neural network system for optical character recognition. In this system, the input is those printed characters. You can see, for a human, we can recognize those characters easily. Although they are in different fonts, we can recognize they all stand for capital A. We want to build our neural network, so through the process of our neural network system, we can get our output, recognize those characters as capital A. Usually, our artificial neural network looks like this. On the left side, we have our input layer. On the right side, we have our output layer. And in the middle are those hidden layers. So, when we consider optical character recognition, we have input those printed characters on the left side. And through the process of this neural network system, we have our output. That is, for example, we put input here, and then we can recognize character A as the output. And how does this work? And usually we have the input here, and then we put a different weight for all those lines towards the output. And based on the different weight, we can calculate the node number of this point. And after we process this layer, we use the different weight which connected layer 1 and layer 2. And then we will calculate all those output for the second layer and keep going doing this until we reach the output layer. And in this dot, we have our function called activation function. What is the activation function? Activation function is like a switch, but it is not a binary. It's not 0 or 1. There are many activation functions. Now I will show you two popular activation functions. One is called sigmoid. So that is, if it's on the left side, it will move towards 0. And if on the right side, it will move towards 1. You can see in the middle, and it can have value 0.5. That is, it's impossible to decide which side. And this is the case when you have a value between 0 and 1. When you have a value between -1 and 1, you can use this second tanh function. So this function is like, if the value is very low, it will move towards -1, and if it's high, it will move towards +1. When we try to build our neural network, we have to train our system first. So, for example, if we want to recognize all those characters, we will put all those characters on the input layer. And because we know the result, at the beginning of this speech, I showed you several characters with a capital A. And we know it should be capital A. So the output we know is capital A. And at the beginning, we just assign some random weights to all those connections. And then we will try to calculate the output based on those weights. This is called forward propagation. So with this calculation, we have our input, and then after the calculation, for example, we say, oh, this character is letter C, which is not correct. What we should do in this case? In this case, we are going to use backward propagation. That means after we got our result, we are going to compare with the result we know, that is the correct result, and then we just adjust the weight we assigned initially to get the correct result. Through this training process, we can finally decide all those weights among those layers. So with neural network, usually the hidden layers are like a big black box. We don't know what's going on over there, but we can see what we input and we can check what's the output. In this video, I'm going to show you a very simple single neural network. That is, we have 3 numbers for the inputs, and then based on the weight, we'll calculate our output. Of course, if you want to build some neural network which is very useful for the real work, the neural network can become very complicated. Here, I just want to show you this simple model, and so you can understand how the neural network works. With the training set, I will have the input as this. 4 input here is A, B, and C. It's 001, 111, 101, 011. And then the output we know it should be the value 0, 1, 1, 0. That means after we combine the input from A and B and C, and then we will reach this value. Let's take a look at this training set. You can see the training input here it starts with 0 for the first example, and the output is 0, 2. And then the second training input it starts with 1, and the output is 1, 2. And the third one, the first input of this array is 1, and the result is 1. And similarly, the last input starts with 0, and output is also 0. So you can see in this training set, somehow final output are all consistent with the first input. It's 0, 1, 1, 0, 0, 1, 1, 0. That means in our training set, basically, this input from A will have a big impact to the final result. Okay, now let's take a look at the Python program. In this example, for the activation function, I'm going to use 10H. And you can see this is my training function here. And at the very beginning, I'm going to assign some random number as the initial weight. So this is random weights at the very beginning, assigned like this. And then I will run 10,000 times to train my model. After I trained my model, you can see the new weights are like this. The first one is 5.39. A second one is 0.19. And third one is 0.34. You can see, just like I mentioned before, because the first node has a big impact to the final result, it has a very heavy weight. It's more than 5. The other two is below 1. It's very small. So after we finalize our model, let's see how it works with a new input. Okay, the new input is 1, 0, 0. We can imagine, because the weight for the first node is so heavy, and if the first node is 1, probably we will get the output something close to 1. Let's see what we will get. You can see if we input 100 to our neural network, we will get 0.99995879. It's very close to 1. Just as we expected, because the first node is 1 and it has very heavy weight, it will give us some number very close to 1. This is the basic concept of neural network and how you can build a neural network in Python. Please provide your comments and subscribe to my channel. Thank you very much for watching.